In PLAI typed, we have lists, like the list combining the numbers 1 and 2, and we have S expressions, like the S expression combining 1 and 2. The reason these two things print the same way is because the difference between a list of numbers and an S expression is just a type difference. Because there's a type difference, even though we can take the first of list 1, 2, we cannot take the first of the S expression 1, 2. Because an S expression is not a list at the type level, but we can cast the S expression to a list, and then we can type the first, and then we get the 1 out. Notice that it's a 1 as an S expression, not 1 as a number, which we got before, but the point is that these things are represented the same way, and the same operations can work on them as long as we coerce the types. Besides pulling apart an S expression, we could create one. If we have a list of S expressions with 1 and 2, we can coerce that from a list to an S expression. When we're constructing these S expressions, however, we also have a shortcut, which is the backquote operator. For example, if we make list plus 5, 6, then that makes the list with 1 and 11. Similarly, we can use backquote 1, and instead of writing 11, we can escape and add the numbers 5 and 6. That would give us the number 11. That doesn't work, but we can coerce the number to an S expression, and that works to build up the S expression containing 1 and 11. This escape is particularly useful if we have a very large S expression with all sorts of things around the part that we want to compute. This notion of S expression, and especially the quasi-quote notation with the unquote to escape with an expression, all of that comes from actually the untyped world. We have all of the same things if we change this to language racket. We have the list 1, 2, and we have an S expression containing 1 and 2, but notice no type is printed out. We're in an untyped language, and in fact we can use first and rest on the S expression notation, and we can use backquotes. Let's see. And we can use backquotes to escape a computation without having to do an extra coercion as well. The convenience of using S expressions in an untyped language is going to be relevant as we look at generalizing syntactic sugar and making that generalization work in one of our curly brace languages, which is an untyped language.